Hi everyone, good afternoon, welcome back. Welcome to OWASP AppSecEU and the DevSecOps track. My name is Nathan Britton, I'm an OWASP volunteer, I'm an OWASP chapter leader in Birmingham in the West Midlands in the UK, and pleased to help today's session. So we're going to talk today all things DevSecOps and the importance of getting security into your CI/CD pipeline. So during the next 45 minutes, you'll hear from Joe present his talk on security as code, a DevSecOps approach. That'll last about 45 minutes, and then 10 minutes we'll have for Q&A afterwards. So please, within your Hoover app or the Hoover browser, please locate the Q&A session and add your questions there, and I'll keep an eye on them. And at the end, we'll grill Joe with all those questions. But that's all that I need to say. Enough from me. I'd like now to hand over to Joe, who's part of GitHub Security Lab, to begin his presentation. Go for it, Joe.
Thanks so much, Nathan. Hi, everyone. Welcome to my presentation. I'm sharing my screen, so we get started. So welcome, everyone. Hello from the GitHub Security Lab. My name is Joseph. A bit about me is that, first of all, I am doing security from my early teenage years because it was my own way to provide dedicated and ethical service to organizations and the society as a whole. Through the years, I studied software and I focused on cybersecurity. I've worked as a consultant for IBM, advising directly CISOs and CO on pressing security matters. And for the past year now, I'm part of the GitHub Security Lab because I want to help software developers directly and the open source to secure the open source software that we all depend on. Some career highlights include a zero-day vulnerability for a top 10 cryptocurrency back in 2018. I showed through my thesis a way to pause legitimate transactions randomly as a result of attacking directly blockchain innovations so that we secure them. And other career highlights lately include a YouTube series that is called Security Bytes that you can find in the GitHub channel. In this series, I focus on common mistakes that software developers are making so that these are avoided and everybody is coding securely. The gap I found in the market, let's say, and I introduced this series was that normally you see videos that hackers are trying to exploit code and trying to show you how to make benefit of bugs. I chose the other way. I use code that I see often online and I show what is wrong with it. Other publications I have lately include blogging, again in the GitHub official blog. Like, for example, today's most common security vulnerabilities explained alongside how you can get help for free from GitHub to avoid those. And I'm writing all this content because I'm part of a team with the goal to secure the world's software together with you. We are doing two things towards that direction. The first one is to produce educational content like the one I just described. But also we are doing security research, which includes 331 zero days over the past 26 months that we publish and we explain in our Twitter and in our blog. And at the end of the presentation, I'll speak a bit about the future and what we are going to publish, because many people are finding those very useful. It has to do with free consultation on how you can secure your open source project and content on security for actions and all these nice features that GitHub has. So today, I'm here to speak about security as code, which is a new DevSecOps methodology that I'm gonna explain how we got inspired from and show you how you can apply in your code starting straight away after today's session. First of all, I want to start with a little story that is real. It doesn't come from a Netflix original scenario or from anything like that. 10 years ago, when NASA tried to go to Mars to explore the surface of Mars, they used a little rover called Curiosity. So that rover would land in the surface of Mars using a little parachute. But in the same way that some of us, when we are going like in a trip with a family, you have a family member asking 20 minutes after you left home if the heater is turned off and if you are sure that you locked your door. Someone in the NASA team asked, are we sure that everything will be working as expected? Do you want to make a final check? Do you want to make a final code review? So there was a snippet of code very similar to the one on screen right now that the NASA engineers took a look and they found a potential vulnerability about it. So I don't know if anybody has spotted that already, but in the first line, you have a method that is expecting an array of 12 elements. But an array of 3 elements is actually being created in line 7, which can cause random memory access leading to random behavior in line 2, because the array is gonna be looped correctly until the 3rd element, and then you are gonna have the elements 4 to 12 accessing random memory. This means that the rover could crash in the surface of Mars. And on top of that, the NASA engineers did something smarter. They didn't just fix that specific vulnerable instance of the code, but they wrote a generic query in the language I'm going to introduce in our demo to find instances of that vulnerability in the rest of their code base. So they wrote a generic CodeQL query in order to pick similar issues in the code. And they found 30 other issues. These 30 other issues could together lead into the rover being crashed. So this will be a very, very late fix in production. It's a costly one. It causes effort, time, and potentially money in the case of damage. The smart thing that they did was that they fixed all of them with a single query. 10 years, that was 10 years ago. 1 year ago, NASA sent another rover to Mars, this time called Ingenuity, but they learned from the mistakes of the past. They used a collection of our products alongside CodeQL that we are going to see in today's demo, and they shifted security left by picking up problems like that or others very early in the software development lifecycle, and not just at the end when the rover is literally mid-flight, which is very late in production. So if I would end the presentation here today, it would be just some, oh, today I've learned about a very cool feature that's called CodeQL. I can enable it in my code as well, and I could benefit from the same security as NASA and other teams in the world. Today's presentation is about showing you how you can write your own CodeQL code towards DevSecOps. I'm trying to make you an actor instead of a passive user. Of course, it's open to you to turn it off, to turn it on. I'm going to show you how you can enable CodeQL later. But the point I want to make is that we are working as a community. When NASA engineers write a query to pick up a vulnerability in their code, this query is also available to you, to me, to everybody really. When the security team of another team in another enterprise is doing the same, then this query is available to everyone. And in that query set, you have my team contributing, which is the team with 331 zero-day vulnerabilities. And we also have bug hunters that are contributing queries to pick up zero-day vulnerabilities that they find so that they get paid bounties. So we are all working as a community here. And now I want to introduce security as code. We were inspired for security as code through the lessons learned from DevOps and quality assurance. So traditionally, we believe that historically, actually, DevOps succeeded because the developers didn't need to open tickets to infrastructure teams, and they got their hands dirty with infrastructure. They could write, manage, change, and control their own infrastructure. In the same way, they could now read, execute, and understand readable code without the need to get involved and lose time with other teams internally. In the same way, you have quality assurance. In the pre-agile days, teams will work in silos. So you have the testing team making sure that the code is functional, but also secure, and providing the developers team with potential changes in the code that they want, and some, let's say, recommendations. Today, I think that this approach will not resonate with the vast majority of people because we shift towards a more DevSecOps way of doing things, that people want to have the control in their hands. We got inspired from that, and we want to propose security as code, which is the methodology of codifying security decisions that are then shared with other teams. We therefore expect the security experts of an organization to codify their security knowledge in readable and executable form, and then socialize this knowledge with the rest of the company so that developers can read, understand, change, and execute security decisions that are codified. This way, we believe that the speed of DevOps would not be affected, and security will be a seamless observer just for when there are security alerts that, as I'm going to show you later in the demo, they are very readable, very understandable, explained very well with references, and security can become not a stopper, because traditionally, I know that, especially in the past, we were seeing as people who say no, and stopping the progress and the speed of an organization. The way we propose to do security as code is via a new language, which is called CodeQL. CodeQL is a language that allows you to query code as if it was data by describing what you want to find and not how to find it. This means that it's a declarative language, but it's also a logical language, so that you can use operators like and or to show relationships between what you are looking for. The way that it works behind the scenes is through creating an abstract syntax tree for your code, which is called a database. So this database is relational, and it can find what you are looking for in a very fast way. CodeQL is an object-oriented language, which means that you can benefit from features like encapsulation and inheritance composition, but also the object-oriented nature, which is like relationships in the form of lions are animals, so that you can talk as generic as possible in the same way as NASA spoke as generic as possible, and they pick vulnerabilities across their whole code base. CodeQL is free for open source, and it's also on a paid license for enterprises. I'm going to show you how you can enable it in a bit, but like I said before, the point for today's presentation is to show you how you can write in CodeQL. So my goal today is for everybody to live with knowing the basics of this language. I started as a beginner myself around 5 to 6 months ago, and I got very fast with it very easily and quite quickly because I could benefit from templates. There are so many templates and ready-made code there that is just asking for placeholders in order for you to find what you want. I don't reinvent the wheel in the language, and I don't expect people to reinvent the wheel either. Even NASA or other teams around the world and bug hunters, they don't start from scratch, but you are also very welcome to start from scratch if it's going to help you. We start from a very good level from the existing queries in the code base, in the database, and we are building on top of those. Another thing I want to say about CodeQL is that it now supports JavaScript, Java, Python, Go, Rust, C, C++, C#, Ruby is coming in the next year, as well as Kotlin, and many other languages are in the road. So before going to today's demo, I want to make sure that everybody is in the same line. I'm going to show how I can pick an SQL injection vulnerability for a tailored code base. So imagine that this code base is private to me. I want to use CodeQL to pick up SQL injections, and I want to pick it up in a generic fashion, like NASA did with the vulnerability we've seen. For those that are not familiar with SQL injection, just have a look in the meme, and I'm going to explain the vulnerability in 20 seconds. So this meme is very famous in the cybersecurity industry. It's from XKCD. The root cause of the vulnerability is input sanitization, really. That is either not happening at all or happening incorrectly. So behind the scenes, you have code similar to this one, which is written in SQL, where the developer is expecting a student's name to be added into the database. But the problem is that the developer here assumes that the user is very innocent and the only thing they can pass is indeed a student's name. They trust the user, really. But in reality, if we can see in the SQL code below, someone that has malicious intentions can indeed close the quote that is expected above to close naturally, because you just pass a name, add a semicolon, and through that semicolon, add a malicious command that can be to drop the student's table, or it can be to create another admin user that will have access to the student's database, personal data, card information, etc., etc. The possibilities are endless, really, with an SQL injection vulnerability. I just want to make sure that everybody understands where the vulnerability occurs here. So it occurs in the way that the untrusted user input enters into the database. And just before start writing on CodeQL, I want to introduce some terminology that it's going to help us with the templates of the language. First of all, we have sources. Sources are vulnerability sources that are places in the program that receive untrusted user input. In the example I've shown you, the source is this one. Is the execution of the call of the insert into method, where you have untrusted user input entering the code base. And then you have sinks. Sinks are places in the program that the malicious user input is actually being executed. If you don't have malicious input execution, you have an unexploitable vulnerability. In our example, if the untrusted user input never reaches the sink, we don't have a vulnerability. So we will suffer from many false positives that my demo is going to focus to lower. The sink is actually the place in the program that the SQL command is actually being executed. It can be the query execute command. You do have a vulnerability when you have data flow from sources to sinks. In no other situation. That's the only situation where you have an SQL injection vulnerability. Now, let's go to our demo to start writing CodeQL together. I'm switching to my code editor, which is the VS Code. Here on the left, I have installed the CodeQL extension, and I have made the code base, the intentionally vulnerable code base that together we are gonna find vulnerabilities on. I create the abstract syntax tree by using a command from the CodeQL command line, which is here. It's the mobile shepherd from OWASP. It's an Android mobile app that is intentionally vulnerable. So if we explore the database, the code base a bit, Just a note here, if I use the word code base or database, they are interchangeable because the code base is transformed into a database here. So if we have a look around, I want you to consider a mobile app, like that's my phone here. You enter in the mobile app and you have a normal application that is asking for your username and your password to log in. Imagine something very similar. The code behind asking for your username and your password to log in is in here, line 98 and line 99. In line 98 and line 99, we can see that we have the method getText, which is responsible for getting the user input into the code base. You need to remember that that's the room for error. It's the place where a malicious user like myself can enter something malicious in the code base, or a user that is trusted can enter something which is not malicious. But that's the same place. That's the place we need to focus our attention. So if we plan a bit now, and I'm back to my slides, the source is essentially the getText method. The way CodeQL works is similar to SQL. You need to find all the methods in the program and then filter just those that are the getText method. So the way that we are going to write this code today is that first, we are going to find all the methods in the program, no matter what they are doing. And then I'm going to specifically restrict those methods that are accepting user input. So if I switch to my code editor, starting from scratch, I'm going to import the standard library from Java, which is going to give me all these nice out-of-the-box ready-made functions so I can be productive and I can write code faster. So I'm importing Java. And then, like I said, similar to SQL, I can use from, where, select, close. Like, for example, from all the methods of this code base, give me some methods that meet some specific criteria and return those methods by the select. Let's first start, since we are beginners now, and in a few moments we are going to be knowing all the basics. Let's start from two keywords, the from and the select. In plain English, I'm going to ask the language to give me from all the methods in the program that are being invoked, all those methods. So I'm going to use a type, which is called method access, which is going to return all those accessed methods. And if I hover on top of it, I can get some nice help here. A method access is an invocation of a method with a list of arguments. I also want to have a variable, which I can name call, or I can name C, I can name whatever I like. And I want to have all these methods that are being invoked returned. I'm going to run this now. And in fact, on the right-hand side, I have all the methods that are being invoked in the program. So if I click in here or here, you can see where each method lands. So by this, I can also say that I can use CodeQL just to search my code and get myself familiarized with the code, not necessarily to pick security vulnerabilities. So let's get a bit more of help here. Let's be a bit more specific by restricting the invoked methods to just those that are receiving user input. I can use the code completion functionality of my IDE and get proposals of what functions I can use. Since I'm looking for an argument, I'm looking for a method that is a specific method, I can use get method. So if I hover a bit, get method gets you the method accessed by a specific method. It expects something specific, so I can use further methods like the has qualified name, which it's expecting a package name, a type, and a method name. So when I hover over, you can see how I get the help here. And until I complete the package, which is android.widget here, and the type, or the example with the animals, where a lion is an animal, we have the generic type of edit text. And the specific method I'm looking for is the get text. Before I run this, I just want to emphasize the chaining functionality, how expressive it is, and how I can use inheritance composition to get from one place to another. So I just ran this, and I came up with the 3 invocations of the getText method in the program. It doesn't mean that they are all vulnerable. I just want to emphasize that where we are now is we know the places of the program that receive untrusted user input. It can be malicious or it can be okay. So if I go back, so far we have all the methods of the program that are receiving user input. Let's now find the sink. The sinks are the places in the program that you have SQL being executed. Specifically is the raw query method, but the first argument of it by nature, because the rest of arguments are like decoration to the query being executed. So if I go back to the code and I go to the line 147, we can see here that we indeed have the raw query method with the first argument being passed. And that's exactly our sink. Normally, in my day-to-day job, I wouldn't go to the code and search for the raw query method manually because I will use CodeQL to do this. I will just familiarize myself with the language, which is Java, with the Android package, and I will then know what are the pain points and what to look for. I just want to show you where everything is invoked so that we are all more clear and on the same page. So the tactic that I'm going to follow to pick up sinks in the program is the following. I'm going to start from all the methods in the program. I'm going to further restrict my input to those methods that are the raw query methods specifically. But because I want to avoid false positive, reduce the pressure to the security team and to the time that security engineers would spend to fix stuff and developers, etc., I will be more specific and I will only ask for the first argument of the raw query method. If that first argument is actually being set, I know that I have sinks. So if I go now back to my code and I can code this, on top, I have the same functionality like before. For example, the get method has qualified name. You see some change here. We are not on the Android.widget. We are looking for the NetSQL Cipher database. The SQLite database is the hierarchically higher method. And specifically, we are looking for the raw query. But like we said, we are looking for the first argument of the raw query method, so we avoid false positives. So I can use the logical features of the language here by using the AND operator and further restrict the call. So I can say that what we are looking for is the argument in the first position before the comma. So I'm also introducing another variable here, which is the variable argument, which is of type expression, because anything that is passed inside a method like get argument or the raw query method is of type expression and it's an argument. So I want to be more specific here. So I'm looking for calls in the raw query method where the argument is the one in index, where the argument is the call to that raw query method in index 0. Because we are software engineers, index 0 is the first argument. So in plain English, this query here says, get me all the invocations to the raw query method that are having the first argument being set. So far, so good. We have the sources, the sinks. What we are looking for is confirmed data flow from sources to sinks. Without confirmed data flow, there's no SQL injection vulnerability happening. And now I'm going to show you the real power of the language. By showing you the data flow template, I didn't write this code. This code was ready-made from the language. Maybe the NASA team wrote this code, maybe my team wrote this code, or someone else from the community. What is asked from me is just to fill these to-dos here in line 15 and line 19 with the functions that we've done before for sources and sinks. If I explain the code a bit here, on top you have some metadata that are coming with the language. You don't need to bother with them. Then you have the Java library being imported alongside some other libraries that are going to help with the data visualization. And the data flow, which is going to help us to find confirmed flow from data, sources, and sinks. Then you have the real power of the language, which is what we bring on top of SQL, which is the object-oriented nature. You have a class here, a class that extends its super type, getting everything from its super type. So it can make you more productive, less errors, much easier to write, less for more. In here, you see the constructor that you can use to initiate further classes. And then I want to speak a bit about predicates. Predicates is the same thing with functions in other language or methods. They allow you to reuse logic. They can encapsulate portions of logic and create functions that are reusable. So since we have time, we are 33 minutes past. Let me show you how I can transform this to be a predicate so I don't write the same code over and over again. And I give my team reusable code. So for example, if I create a predicate here and I name it sink, that is expecting a method access and also an argument, I can copy and paste what is in the where clause like that. And in here, I don't need this. I'm just gonna use the predicate from above, passing inside the call and the argument. So if we run this, on the right, you are gonna see that we arrive at those raw query invocations that the first argument is being set. So back to the code here. I also want to introduce another keyword that I find very, very useful and very readable, which is the exists keyword. I like to joke a bit about it. Is less context is more. So for example, I'm gonna delete the fact that we have method calls here, because at the end of the day, vulnerabilities start with method calls. So I'm completely deleting the method call here. The sink is now expecting an argument. And I can use the exist keyword, which goes like that. There exists a method access such that this and this happens. So in plain English, here we have a variable that lives and dies inside the context of a method, which makes your code much faster, much more readable, way less confusion for a team to understand what is this guy talking about. So if we run this code, we expect to have the exact same results as before. So having said this, let's go back here and fill the to-dos. So I'm going to use the same tactic as before. There exists a method call such that when this method is the get text, I know that I have untrusted user input entering my code base. So if I copy and paste this here, here, the final thing I want to show you from the presentation is this idea for nodes. And you see that nodes is a special type in the library data flow here, because if I switch back, we represent data flow by nodes. You have this idea of a node A having a flow to another node, node B. So in the specific template I show you, we need to represent everything under the node type. In the same way, before I used the expression type and the method access type, I now need to use the node type so that I speak the same language with my template, which what I mean is that when there's a method access, that is the get text method access, I want this node to equal that method call. So if you imagine that on the left here, we have the get text expressed as a node. On the other hand side, for the sync, we are going to have the specific argument, the first argument of the raw query method being the node destination. So if we express this in the same way, there exists a method access such that something happens, which is more specific. It's ready from here, actually. Or copy and paste that. The only change I need to do is that here we don't have the expression argument. We have the node expression, which is like that. If I run this code, you are going to see the real power of CodeQL, which are confirmed SQL findings with specific pathways without any false positives. So I just run the code, and on the right, you can see we have two SQL injection vulnerabilities, confirmed findings. Let's break them down. The first finding has two paths. So as security professional, I need to fix all the paths. But from my experience from before, I can guarantee that the best teams I've seen in my life can fix one or two paths at a time. They need to run more tests and they need to fail more to fix everything. If I go here and I click on the path, I can first click on get text to see the first, let's say, path of the journey that this vulnerability starts from. So the first is where the first untrusted user input is getting to the language, which is here, line 98. Let me zoom out a bit. Let's follow the flow. If we click on check name, you have that this check name is now passed into a try catch block where we try to understand by using the login method if the user has passed credentials that are indeed part of the database, i.e., if the username exists in the database. And if I now follow the login method, I go to the signature of the login method that is expecting a username, etc. And then this specific flow continues into the raw query where you have the place in the program that is being passed to the raw query method, which is going to execute an SQL command. That's the very first flow. The next flow is this one, which is actually the exact same way of doing things, but instead of checking that the user has passed the correct username and password, so the login method equals true, it now equals false. So I want you to notice the difference between the lines 102 and the lines 116. you have the exact same flow, but the one equals true, the other equals false. In reality, they are both vulnerabilities. I've seen many teams fixing just the one of the two, but in reality, you need to fix everything. So the CodeQL will give you all the pathways to that place. And in here, we have another confirmed finding that is now the password, following the exact same journey to the database. And here, that's the one for the password. So I now want to highlight that, okay, this is a very simple example, but in a real code base with flow between tens or hundreds of places, you will need something very powerful like CodeQL to give you all the confirmed flow of the data so that you don't have to follow manually. In general, what you do manually is very error prone, and in cases specifically when you have this kind of let's say equals true, equals false, and all this flow between the code base. If I go back to my slides, I promised to show you how you can enable CodeQL passively so that you can use out of the box all these queries that my team is writing, NASA is writing, other enterprise teams are writing, and the bug hunters. It's very easy. It's a few clicks. If I head to my personal profile and I pick one of my open source projects, like for example, Multipaxos, you can see here that I can just navigate to security, code scanning alerts, click set up code scanning, configure scanning tool, and I can choose CodeQL analysis, which is here. So I click configure, and there's a YAML file being created for me. I can just commit this file, and every time I'm gonna commit and push code, I'm gonna get alerts. I'm gonna show you how they look. I can specify which language I want to pick alerts from, and I also want to specify how vocal is the language. Like for example, I want the language to touch, I want the alerts to touch on quality stuff, or be very like conservative and just give me back confirmed findings. So back to the slides. The next thing I want to show you is how alerts are looking. So if I go to another code I have, another project, I go to security, I click. So here code scanning is already up. I click, sorry, not on the secrets. I need to click on code scanning alerts, view alerts. And I can see here that I have 9 open alerts and 5 that I've closed. If I click on one of the alerts, you have the explanation here. I have use of broken or weak cryptographic hashing algorithm on sensitive data. You see exactly where the alerts are occurring. You have some nice explanation that is clickable. And also on the right, you can see the patterns, CWEs, that you can click and understand more about them. That's how an alert is looking. And finally, to start your CodeQL journey, these are some resources that I found useful in my own journey. CodeQL.com, securitylab.com, get involved. Some CTFs that we ran some time ago. In general, like I said, you don't start from scratch. You start and build on top of code that already exists. And you can be very productive very easily with a template like the one I use for the demo. Finally, there's a new initiative that my team has started over the past 2.5 months, where we open our doors in a project called Community Office Hours. We welcome open source maintainers. We sit down with them for an hour or more through different meetings. and we can discuss the security surface of a program, what their security problems are, concerns. Often maintainers come to us and they don't know what they don't know in terms of security. So we have helped them in defining their security policies. We help them to understand how they can quickly and effectively notify the community about the potential vulnerability in their code base. And this is something that the community has embraced. And when we open some more slots, you can find about them in GH Security Lab in Twitter. We publish our research there, we publish our educational content there, and I would love to have more open source projects so that our impact is growing more and more. So I would like to thank you on exactly 45 minutes, OWASP, AppSecEU for having me, and you for listening to me. Let's use the remaining time for questions. And if you think about questions later, I will be more than happy to contact me in my own media, like for example, Twitter at JKCSO, or you can add me in LinkedIn. And that was it. I'm open for your questions, and let me stop sharing my screen.
Thanks, Joseph. Great talk. Yes, we've got a couple of questions coming in. I'm going to start off with a couple of simple ones actually before we get to those. So a lot of people may be more familiar with SAST, DAST, SCA, those kind of terms. So could you just clarify the high level? Is it a DAST tool? Is it a SAST tool? Is it neither of those? Just start off with that one.
That's a great question, Nathan, and thanks so much to the audience for asking. CodeQL is a SAST tool. I know that DAST tools are very helpful. They can help you find things out when you run real variables on them and find things on the way. CodeQL doesn't run the code. It is not able to pick variables. It's a SAST tool, but something very useful that I've seen from clients and the community is that some CodeQL alerts were not 100%, let's say, correct at the time, but through specific data that they found with DAST tools, they were indeed true CodeQL alerts. This means that the false positives are very low, and it's a product that it can complement your DAST a lot.
I assume, therefore, that you can use the output of DAST scans to then perhaps drive some queries within CodeQL for other projects that you might have in your organization.
Exactly, to reduce the false positives and to have a more data-driven approach in you tailoring your queries.
Okay, so a specific question about advantages, perhaps. So where would you see are the key advantages then between something like CodeQL and a traditional SCA or SAST tool that people watching this video or viewing this will perhaps have in their own organization today?
That's another great question. I think the three main differentiators of CodeQL in comparison to other tools is, first of all, the taint tracking functionality. As we've seen in the demo, in the data flow we had at the end, that's something that other SAST tools are not so powerful on, which is very useful for security vulnerability research, at least. For someone who wants to follow a taint across the way, see where data flows, where exactly, in which situation, like when something is true or when something is false, is something that can save you a lot of time and can make your fixing process much, much easier. The second thing I want to touch on is the open source element of it. Someone can enable CodeQL for free for an open source project and benefit out of the box for all this collective knowledge we've built all together as a community for the past 10 years. The fact that teams like NASA's, my team with the 331 zero-day vulnerabilities, Other teams that are public and we have spoke publicly about, and you can find our interview in YouTube, is the one for Mercado Libre, which is the Amazon of South America. They can also contribute queries to us. So this is very powerful. When you are an enterprise or someone who wants to have private repo, you can build on top of that. And finally, the other thing that I think differentiates us is the amount of time and the resources. I don't want to say resources and speak about people. The teams we have that they focus on reducing false positives. No query is gonna make it to the database unless we absolutely, unless we absolutely reduce to the minimum false positives. Some people joke in my team and they are like, oh, it's much easier for you to like achieve this super amazing thing that is, I don't know, once in a million than a query getting into our database that is not polished for the minimum false positives. So these three.
Okay, thank you. And actually, we've got a follow-up question really around the time and around the maintenance to create the tests, especially if you're in an organization which has some pretty big applications that they've built, perhaps over a number of years, and even ones that perhaps haven't had CodeQL or even any security scanning previously. What's the kind of practical maintenance elements that you can give us your experience about?
I will say that it doesn't have a huge overhead. Like you see on my demo I ran, I specified the getText method as the method where untrusted user input is coming in, but anybody could just be way more generic and just say all those methods of type edit text. That's, if you remember, when I've used the hash qualified name, I used the package android.widget, the generic type edit text, and then instead of saying get text, I will say any. So an organization with rapidly changing code, to avoid fragile queries, they can be as generic as possible. They can use the object-oriented nature of CodeQL by using the generic types, and then they can use the keyword any so that they can get started quickly without the false positives and the overhead that an organization would need.
Okay, thanks. Another question actually is regarding the sort of possible. It's a very powerful tool. It's very obvious from the demo how powerful the tool it actually is. What else could we use it for? Right, we can obviously find vulnerabilities. I'm thinking whether manual code reviews could possibly use it, peer reviews of code. But what else? Where else could we use it?
I will say that's another great question. I will say to search your code. So I've told you about the zero-day vulnerability I found in 2018. I wish I knew about CodeQL at the time. The way I found this vulnerability was by reading the whole code for Bitcoin that another project has forked. And I found a vulnerability for that top 10 cryptocurrency that was forked for Bitcoin. I didn't know about CodeQL at the time. So I had to manually go over the code and establish mental relationships and go from X to Y. I could use CodeQL for that. I could write a few lines of code to go specifically to that method, understand or express in code where I want to go next, what I want to find instead of how to find it, and in general, search for all those pain points in the code. It can be just to familiarize yourself with the code base, not specifically or necessarily for vulnerability research. It's a methodology of querying your code as if it was data.
So how long has CodeQL been around then?
It's around for 10 years. Okay. More than that, it's around 12 years. Originally being created by Semol, a small startup in Oxford, by 2009. And then after 10 years of implementation and working with enterprises, it was acquired by GitHub in late 2019. And GitHub was previously acquired in 2018 by Microsoft. So think about CodeQL being the code scanning feature of GitHub and also for Microsoft.
Okay, and just going back to actually on the scanning element, we talked about SCA, the dependent. Will it find dependencies or insecure dependencies in your code?
I love this question because it's so pressing. Many organizations are suffering from supply chain attacks. They are so prevalent these days. The way I will do it is the following. I will use 100% CodeQL to scan the dependencies I have, if those are open source. If those are not open source, I will use Dependabot in order to, which is another feature we have, another product we have, to get notified about secure versions so that I can update on the spot, really. So to summarize here, while CodeQL is a tool you can use to search for vulnerabilities in code or in general to query your code, you can query your dependencies for vulnerabilities if those are open source. In the same way, you will query your own code.
Okay, thank you. Can you just run through the languages it supports as well? It's quite a long list, and I think it's been added to as well. So, of
course. So my demo was in Java. Other language supported is JavaScript, Python, Go, Rust, C, C++, C#, and it's always how can I say, CodeQL is always under development. There are huge software engineering teams that are introducing new features in the language based on user feedback. And new languages that are coming is Ruby, actually very soon, in a few months from now. Kotlin as well is coming, and many languages are underway that I can't really publicly disclose unless they go on the public roadmap.
Okay, cool. So we're running out of time. We've got about a couple of minutes, I think. Try and squeeze in perhaps another one or two. So if people were starting from scratch, can you just remind us how they would get it onto their projects? Just a very quick overview of how they might enable that.
Sure. So can I share my screen?
Yeah, we've got about a minute.
So yeah, that's VS Code. You just go to extensions, which is here. By clicking extensions, you write CodeQL. That's the official CodeQL extension. When you install it, you are gonna see CodeQL being here, and you can connect with the code base you want to query by passing in a GitHub URL. That's pretty much it. Otherwise, you need to compress, create an abstract syntax tree for your code base and connect it to the VS Code. It's very simple. It takes one click. And from there, you are going to have all the queries that exist from before, all this collective knowledge. You can either run the queries out of the box, or you can double click in an existing query like I did with the data flow template, and you can code a bit on that. If you want, you can start from scratch in the way we started with the source.
Great. That's great, Joe. What a great session. Really appreciate your time. I really appreciate you coming on to AppSecEU. And once again, thanks to me and everyone else for your time today.
Thank you so much for today. And thanks so much. It has been amazing. The organization was superb. I'm very looking forward to hear back from the audience and to help everybody. Let's keep in touch.